Our project title is Trainobot. We are three members in our team, myself, Arpit Arora, and two of my friends, Nitish Kumar and Abhishek Ivy. The project is done under the guidance of Vinay Talageri sir. Our problem definition is to design a machine which is semi-automatic, portable and user-friendly, which can train, should be able to draw simple and different types of geometric shapes, should be free in movements, the machine should be less than 1 kg and it should not exceed the dimensions 100 into 30 into 10 centimeter size. The total cost of the bot should not exceed Rs 3000. The machine should draw different geometrical shapes. It should have an indicator to indicate start and stop of the process. This is the functional clustering. Under trainable bot, we have 4 different functions: notification, holding mechanism, writing mechanism, and training mechanism. We have divided the functions into 3 different clusters. Under notification, the function is to notify after completion. Under holding mechanism, the functions are holding the pen, able to move to draw, and holding the paper. Under writing mechanism, the functions are should be able to rotate and easily move up and down. Under training mechanism, the functions are it should be able to copy the masterbot and at the same time the masterbot is drawing. The subsystems identified are the first one is training, the second one is copying, and the third one is box with switches. We have generated 3 concepts. This is the concept 1. This is the slave bot and this is the master bot. These are the shafts which are connected by U-clamp. The servo motors are present in the slave bot and similarly potentiometer is present in the master bot. This is the main stand and these are the switches which will be used to carry out the processes. This is the drawing pen and these are the sheets. This is the concept 2 in which rack and pinion mechanism is used. Here servo motor is present in the slave bot and DC motor is used for the sliding purpose. Similarly, potentiometer is present in the master bot. This is the third concept in which spider leg mechanism is used. These are the robotic arms, servo motors are present, this is the stand and drawing pen is present. We have selected the concept 1 as it is the most suitable and effective out of the 3. Now let us move to the virtual implementation part. Let us look at the 3D model of the entire system. So this is the 3D model of our entire system. Mainly it consists of 3 subsystems: box with switches, training and copying. Coming to our first subsystem, which is box with switches. This is the on off switch which is used to activate the system. 2 push buttons and 2 LED lights are there. The first push button is linked to the training subsystem and the second push button is linked to the copying subsystem. Now coming towards our training subsystem, it is also known as the master bot. Here in this subsystem, each joint is attached with the potentiometer which we have downloaded from the website GrabCAD, and at the end a pen is attached with a pen holder. Now coming towards the working of this subsystem, when we are supposed to write something, all the 3 joints will move along with the potentiometer which are attached on it, and those readings of the potentiometer will be stored in 3 different arrays. Now looking forward to a demonstration video. Now when we are supposed to write something, we'll hold a pen and start writing. The joints will move along with the potentiometer and the readings of the potentiometer will be recorded. You can see how the joints will move. Now coming back to our final 3D model. This is the copying subsystem, which is also known as the slave bot, where each joint is attached with a servo motor which has also been downloaded from the website GrabCAD. Again a pen is attached at the end. Moving towards the working of this subsystem, it takes the values from the 3 arrays and map it with the angles of servo motor ranging from 0 to 180 degree. And the same process is repeated again and again, which helps the slave bot to write the same thing written by master bot. Now let me show a 3D model from different angles. You can have a look here. 3 potentiometers have been attached on the training part and 3 servo motors have been attached on the copying part. We have used 3 different links which will help us to write very easily. So this is how our whole system works. This is the circuit diagram of the entire system. Here 3 potentiometers are present, 3 servo motors are present, 2 push buttons are there, 2 LEDs are there, and rest of the required parts are also there. This is the flowchart of the entire system. After start, it will check button 1 or button 2. If button 1 is pressed, it will read potentiometer values, pass potentiometer values to Arduino, map with servo motors, and store potentiometer values. Now if button 1 is not pressed, it will check whether button 2 is pressed or not. If button 2 is pressed, it will read potentiometer values from Arduino, map with servo motors, and start writing. If none of the buttons are pressed, it will stop. This process will continue again and again. This is the bill of materials required for the entire system. We require acrylic sheet for the base. Bolts will be required for the links. Again, acrylic sheets will be required for the link joints. We also require 10K potentiometer, 4K servo motor, base chassis, push buttons, on-off button, Arduino Mega, 9-volt battery, 12-volt adapter, and LED bulbs. This is the motor sizing and battery sizing of the entire system. In motor sizing, our robotic arm requires 3 MG995 servo motors. F equals to m into g, where m mass equals to 200 gram, that is 0.2 kg, and g equals to 9.8 meter per second square. F equals to 0.2 kg into 9.8 meter per second square, that is 1.96 Newton. Therefore, force equals to 1.96 Newton. We know that torque is given by T equals to F into R, where R equals to 2 cm, T equals to 1.96 Newton into 2 cm, that is 3.92 Newton centimeter. Now to convert it into Newton meter, we'll multiply it by 0.01 and we get 0.0392 Newton meter. We want the torque in kg centimeter, so we'll multiply it by 10.197 and we get 0.399 kg centimeter. Therefore, by the calculation of rated torque, we require a servo motor of speed 200 rpm. Battery sizing is not required in our case. These are the functional specifications of the entire system. The first function is holding the pen. Its specification is a pen holder will be present. The second function is slave bot should be able to copy master bot. Its specification is slave bot will copy the movements of master bot. The third function is to repeat the process. Its specification is the same process will be repeated using servo motor until button is pressed. The fourth function is it should indicate after completion of each cycle, and its specification is there will be a beep after completion. Let us see the modeling and simulation part in Tinkercad. First, we need to store 5 values of each of the potentiometer in 3 arrays, which will be used to map the servo motors. This green LED shows that the system is on, and red LED blinks whenever button 1 is pressed. Whenever this button is pressed, one value of each of the potentiometer gets stored in the array. You can see that this LED blinks when this button is pressed. Four values of each of the potentiometer is stored. Now once 5 values are stored, we will press the button 2 and the servo motors will start playing continuously. The corresponding angles of the servo motor will be displayed on the serial monitor. Thank you.